5.4a, we are talking about sum and differences in terms of trig. Let's just start off with an example. Let's say we have the sine of 43 pi over 6 minus 19 pi over 3. And we want to solve for this. So the sum and differences allows us to use the amounts that we already have, 30, 60, 90, and 45, 45, 90, to break up other angles that would be similar but not exactly to get those particular functions. So first, let's subtract this. So we have sine of 43 pi over 6 minus multiply the second term by 2. So we have 38 pi divided by 6 here. This equals then the sine of 5 pi over 6. Okay, 5 pi over 6 is the equivalent to, if you drew a quick picture, it'll be down, actually, it's just one less than 1 pi, so it'd actually be up here. And this would be 5 pi over 6. And it is a pi over 6, which makes it a 30 degrees. So this is a 1. So then this is a 2. This is a root 3. Well, this is a negative root 3. So the sine of that would be my opposite, which is 1 over 2. So sine of 5 pi over 6 is 1 over 2. So my answer is 1/2 for that one. Let's try, but let's say something different. So instead of say 43 pi over 6 minus 38 pi over 6, what if we had it separately? What if we had it separate? So what if we had sine of 43 pi over 6 minus the sine of 19 pi over 3. So now this is two separate equations that we have over here. We want to break down the 43 pi over 6. So that is a 30 degree angle. And if I try to take away 2 pi's, the largest 2 pi that I can think of from 43 pi over 6. So if I take away, let's say, 7 pi over 6, or let's say here, 2 pi. So each time we want to take away 12. So let's say here, 43 minus 12. That's a 2 pi. 43 minus 12. That gives me 31. I'm going to keep subtracting 12 because that's 2 pi until I can't subtract anymore. So if I subtract 12 some more, this gives me 19. Going to keep subtracting 12. 19 minus 12. Oh, we got a 7. So this is what I really want to take is sine of 7 pi over 6 minus the sine of, now I got 19 pi over 3. I'm going to subtract 6 because that's 2 pi. 6 divided by 3 is 2. So 19 minus 6 is 13 minus 6 is 7. Oh, minus 6. And that give me 1. So minus a pi over 3. So these are my actual angles that I'm really using. 7 pi over 6 and pi over 3. My sine of 7 pi over 6 is technically here, right here, because it's 1 pi over 6 over 1. it's 30 degrees. So this is 1, this is 2, this is negative root 3. So it's 1 over 2. So this is 1/2. And then the other one, pi over 3, that's here. And that is a 60 degrees. So my opposite is root 3, 1, 2. So my number is root 3 over 2. So root 3 over 2. So it's 1/2 minus root 3 over 2. And that would be my answer. If you're trying to put it in WebAssign, it might want you to have it as 1/2 times 1 minus root 3. They're the same terms, but WebAssign is very particular. Let's do another example. Let's say we have cosine of 2 pi over 7 times cosine of 6 pi over 5 minus the sine of 2 pi over 7 times sine of 6 pi over 5. So this is long and lengthy, and I don't necessarily want to do all of that. So what I can do using my trig identities is of cosine of A and cosine of B minus sine of A times sine of B is equivalent to cosine of A plus B. So with that, I can rewrite my equation to make it easier to solve. So then this becomes cosine of 2 pi over 7 plus 6 pi over 5. I just need to combine them. So this makes, here we want 35. So 10 pi over 35 plus 35, which is 42 pi over 35. So that is cosine of 52 pi over 35. And that is the most simplified form that we can work with right there. Let's do one last example. What if we had an angle in which we don't have a definition for or don't have that in our memory banks, but we can break that down into different angles. So let's say we had negative pi over 12. We don't know how to do negative pi over 12, but we know that pi over 12 is equivalent to pi over 6 minus pi over 4. So now we can use our difference formula to solve for this. So our difference formula, so let's say we want to do sine first. We eventually want to do all of them, but first we want to do sine. So sine of u minus v equals sine of u cosine of v minus cosine of u sine of v. What does that mean for our equation? That means to find our sine of negative pi over 12, we want it to be sine, actually we break it up to pi over 6 minus pi over 4, or 30 degrees minus 45 degrees, which is the same thing as saying sine of pi over 6 times the cosine of pi over 4 minus the cosine of pi over 6 times the sine of pi over 4. So now we just got to figure what those are and then simplify. I'm going to draw two triangles here to the side to kind of remind me of what we're dealing with. So pi over 4 is a 45, 45, 90. So it's 1 root 2. And pi over 6 is a 30-degree angle. So it's 1 root 3, 2. So sine of pi over 6 is 1/2. Cosine of pi over 4 is 1 over root 2. Cosine of pi over 6 is root 3 over 2. And sine of pi over 4 is 1 over root 2. Combine, multiply through. So this is 1 over 2 root 2 minus root 3 over 2 root 2. They have the same denominator, so this is actually 1 minus root 3 over 2 root 2. And just like that, that is my sine. Now let's find my cosine. My cosine of u minus v is the same thing as saying cosine of u times cosine of v plus sine of u times sine of v. Well, here, my cosine of u being this is u, and this is v. So here my cosine of u and v is root 3 over 2 times cosine of v is 1 over root 2 plus sine of u. Sine of u is 1/2 times sine of v, which is 1 over root 2, which is root 3 plus 1 all over 2 root 2. For my tangent, I could use the tangent formula, or since my sine and cosine have the exact same denominator, the 2 root 2, I can multiply or divide them each other. So we know tangent is the same thing as sine over cosine. So this is the same thing as 1 minus root 3 over 2 root 2 times the inverse, which is dividing, times the inverse of our cosine, root 3 plus 1. The 2 root 2's cancel each other out. We are left with 1 minus root 3 over root 3 plus 1. I can then multiply by root 3 plus 1 over root 3 plus 1. Not plus 1, minus 1, because I want opposite perfect squares, difference of perfect squares in my denominator. This will leave in my numerator, if I FOIL, root 3 minus 1 minus 3 plus root 3 over 3 minus 1, which then simplifies to make 2 root 3 minus 4 over 2. I can factor out the 2, divide out the 2 from the numerator and the denominator. The 2 cancel everything out. This makes 2. So this is actually just root 3 minus 2 for my tangent.